Which algebra properties are used to prove geometry statements? This is from task 6.8. Make sure this title goes at the top of your paper, and we're going to answer this question throughout the video. Okay, here's a reminder of how your notes should look like when you're taking notes from a video. You're going to have your section title at top, notes go in the right hand column, and in the left hand column you have the video titles. For this section, it's going to be 2 video titles, and once you've gone through and watched the videos and created your notes, then you'll go ahead and do a summary. Okay, I encourage you to pause the video right now and copy everything you see on the screen, and then when you're ready to follow along with me, resume the video. Okay, I'll assume that you paused the video. Let's begin. In geometry, you accept postulates and properties as being true. And we've talked about some of them, like the segment addition postulate and angle addition postulate. We accept those to be true. You can use deductive reasoning to prove other statements as well. Deductive reasoning is the process of reasoning from one or more statements to reach a logical, certain conclusion. So we'll be able to use statements or use geometric shapes to go ahead and prove some different geometry statements. And we'll do that by using deductive reasoning. Listed below are some of the properties of equality from algebra we assume to be true, and we can also use to prove other geometric statements. So here we have properties of equality. I'll just go through a few of them. We have the addition property, and notice that if you add the same thing to both sides, like C, you'll end up having them still equal to each other. The subtraction postulate is subtracting the same thing from both sides. Multiplication property is when you multiply both sides by the same number. Division property is when you divide both sides by the same number. Reflexive property is when you have a statement that equals itself, like a true statement, A equals A. Symmetric property is when you switch, so you have A equals B, then B equals A. The transitive property is when you say A equals B and B equals C. However, if you take out the B's, we can then say A equals C. And that's what this last part says here. And there's also the substitution property, that if A equals B, then B can replace A in any expression. Make sure you have all of these properties of equality down, because you're going to use some of those in class. Here's one other property that you're very familiar with, and that is the distributive property. So go ahead and add that to the list. And then here's an example of the distributive property. Okay, here is our first example. We're going to fill in each missing reason, and we are given LM bisects angle KLN. They're really talking about this angle right here. It bisects it. When we know that segment bisects an angle, we're saying that the angle is split into equal halves. So I'm going to go ahead and write on there equal halves on, the markings that we get for equal angles, which would be this. So those are equal angles there. And so now we can begin with a small little proof here. So first part is we're going to say LM bisects angle KLN. And our reason for that is that it's given to us. That information is given, and that's very important, because once we can have that piece of information, it helps us to do more of the deductive reasoning that we need to do. Now we're saying that because they bisect each other, then angle MLN is equal to the measurement of angle KLM. And I showed you that by doing this little marking right here in red. And this is definition of an angle bisector. There's the reasoning that I was talking about. So that means that we can go ahead and write KX, or 4x, which is the measurement of angle MLN, is equal to 2x plus 40, which is also the measurement of angle KLM. Then we can solve by subtracting 2x to both sides, and we get this new equation. And then we can divide both sides by 2 and get x equals 20. And we went ahead and solved for the variable 20. And if we wanted to find out the angle measurement, we could just plug in x for 20 here and find out those angle measurements. But that's not what they're asking us for. They're asking to go ahead and give our reasoning for why we did this work here. And so I'll take it, or before I take it away, I'd like you to try and think of all the different properties of equalities that could apply to this problem. Go ahead and pause the video and see if you can figure out what those reasonings would be. Okay, I'll assume that you paused the video, so I'll go ahead and show you the answers. Here we have, when we did this part here, we were talking about the substitution property. We already set up that these two angles were equal to each other, so we just substitute in the values for those angles from the given picture. Then we subtracted 2x to both sides, so that was the subtraction property of equality. And then we divided both sides by 2 and got x equals 20, and that's the division property of equality. So sometimes you will have to defend your position or the things that you do to solve a problem. Okay, at the bottom of that list that I gave you of the different properties of equality, there were also the mention of the symmetric, transitive, and reflexive property. But you can also use properties of congruence to justify or prove other statements. And so here I gave you examples of segments and angles. If you say that AB is congruent to the same segment of AB, or angle A is still congruent to angle A, we're talking about the reflexive property. If you say that AB is congruent to CD, and then you switch it and say CD is congruent to AB, or same thing goes for angles, then you can use the symmetric property. Notice that there's a little bit symmetry there, right? We're just reflecting and flipping. And then there's the transitive property. So that's when you're kind of guilty by association, in a sense. If AB is congruent to CD and CD is congruent to EF, then you can take out the CD that they have in common, and then we can say AB is congruent to EF. The same thing follows for angles. You're going to have to use these properties in the next couple of weeks to do some proving of similar or congruent triangles. Okay, make sure you pause the video and write down this entire slide. And for this example, we are going to name the property of equality or congruence that justifies or proves each statement. Notice every time I say justifies, I put proves in parentheses to let you know that we will use these different properties of congruence and properties of equality statements to help us prove geometric statements. And let's take a look at what we have here. I want you to go ahead and write 1, 2, 3, and 4 all down. And then I'm going to, we're going to discuss the answers, but try to do it on your own first, looking at the list that I gave you. And then when you're ready to check your answers, that's when you'll resume the video and you can follow along with me. Okay, let's take a look at number 1. If RS is congruent to TW and TW is congruent to PQ, then RS is congruent to PQ. Notice that we had something in common there, and that was the TW. So if you kind of take that out, then you can say RS is congruent to PQ. What property are we talking about? Well, I mentioned in the last slide that this is called the transitive property. So that is your reason for the statement. That proves, that justifies your statement. Okay, let's take a look at number 2. We have if 2x minus 8 equals 10, and then 2x equals 18. So what do we do to go from this statement here to this statement here? Well, we added 8 to both sides. So the property of equality that we used was the addition property. And the full name would be addition property of equality, but I'm just going to write addition property. And for number 1, transitive property of congruence would have been the full title, but I'm just going to write transitive property. Okay, let's take a look at number 3. We have angle K equals angle K. That's the same angle. And we will have instances where we use this statement. And the proof for this statement, the statement that justifies it, is going to be the reflexive property. If you forgot what that was, look at your previous notes or the last slide. So this is reflexive property. And now let's take a look at number 4. If angle A equals angle B, then angle B equals angle A. And notice we're just kind of switching the position, right? We're kind of reflecting it or switching it. So for this property, we would be using the symmetric property. Oops, I totally spelled that wrong. Excuse me. There you go. Symmetric property. Okay, hopefully you got all of them right. You should have been using the properties in the previous slide or from your previous notes. If you have any questions on any one of these part of the examples, go ahead and bring that to me the class tomorrow and I can explain it in full detail. Just a reminder, don't forget about the tutoring that I have every Tuesday and Thursday after school.